Hi everyone, so this is how you read a t-table. Now this is not your t-table that's in your book, but this is my preferred t-table. I just found it a couple of days ago online, and I like it because I feel like it's a little easier to use than the t-table that's in your book. This particular t-table I put it in PDF form in your content section of your course so that you can print it out and have it with you for the test. Additionally, anything that I talk about here, you can simply use the t-table that's in your book. It's just going to look a little different, but the procedure is still the same. So let's talk a little bit about the various components of a t-table and then how to read them depending on what you're using. So first things first, in order to use a t-table when you have a sample size that's smaller than 50, the first thing you need to know is your sample size. So instead of looking up your sample size, you're going to need to know your degrees of freedom, which is your sample size n minus 1. So in order to look anything up, you're going to start with your degrees of freedom, n minus 1, and then from there you're going to go into one of the columns. So remember always that this is n minus 1, this little guy right here. Let me highlight it. Not what I meant to do, but that's all right. This thing right here, the df, that's n minus 1. So if you're using this t-table for a confidence interval, the good thing that I really like about this particular table is this stuff down here. In the table in your book, it doesn't say what confidence level corresponds to what column. It makes you think about the column. So here, because we're criminologists, we typically only use the 95% confidence interval and the 99% confidence interval. So for confidence intervals, you're just going to basically use those two columns. So say for instance you have a sample size of 10 and you need the t critical value to stick in your confidence interval equation. So n is 10, your degrees of freedom would then be 9 because it's n minus 1. So what you'd end up doing is going to 9, and if you wanted to do a 95% confidence interval, come on there, you'd go over to where that column is, right? And you'd see that your t that you want to use is 2.262. Now if you wanted a 99% confidence interval, you go on over to the 99% confidence interval and you'd see that the t that you wanted to use is 3.250. So you can see how easy it is to read this particular t-table for a confidence interval. The one in the book makes you actually think about the 0.05 and the 0.01 in comparison to the 95 and the 99%. Why bother, right? So I've used this table. So to use a t-table for a hypothesis test, the other things that you need to know for the hypothesis test is whether you've got a one-tailed test or a two-tailed test. So remember, a one-tailed test is when you've got a greater than or less than sign in your alternative hypothesis. So if you have a one-tailed test, you'd look up your alpha level in this row. Okay, these two rows right here are your alpha levels. If you have a two-tailed test, meaning you have a not equal to sign in your alternative hypothesis, you'd look up your alpha level in this row. So, and remember that as criminologists, we typically only use 0.05. So there's the 0.05 for the one-tailed test and the 0.05 for the two-tailed test, and 0.01 for the one-tailed test and 0.01 for the two-tailed test. We typically only use these significance levels, so you know that these are the four columns you're only going to be using for hypothesis tests. You can forget all this other business. And if you notice, for your two-tailed tests, they correspond to the 95% confidence interval and the 99% confidence interval. So, for example, again, if we had a sample size of 10 and we had a one-tailed test and our significance level was 0.05, we'd go to our degrees of freedom of 9, because remember it's n minus 1, and then we'd go over to 0.05. And we'd see that for a one-tailed test, our significance level or our critical value for our hypothesis test is going to be 1.833. So that's effectively how you read a t-table for either one of these things. You just have to differentiate between a one-tailed and a two-tailed and make sure you hit up that correct column.